Hello, good morning, children. So let us continue the chapter Polynomials, part 2. The last class you have seen zeros of a polynomial, values of a polynomial. Then in the present class we will continue our discussion on zeros of a polynomial, the geometrical meaning of zeros of a polynomial. And remember the definition of zero of a polynomial, that the value of the variable for which the polynomial becomes zero. Now for geometrical meaning, you will discuss about the geometrical representation of polynomials and what is the significance of zeros of the polynomial from its graph. And you know that a polynomial takes different values for distinct values of the variable. Consider the example p of x equals 2x minus 4. The variable x can be given any value. Correspondingly, we will get different values for the polynomial p of x. Now let us consider the different values. Some of the values of the polynomial x and px. X stands for the variable in the polynomial 2x minus 4 and px stands for the corresponding value. When x is equal to 1, value of the polynomial is 2 into 1 minus 4, that is 2 minus 4, negative 2. Similarly, when x is equal to 2, p of x is equal to 0, value of the polynomial becomes 0. Then when x is equal to 3, p of x is equal to 2. When x is equal to 0, p of x is equal to negative 4. When x is negative 1, polynomial becomes negative 6. When x is equal to 1 by 2, p of x becomes negative 3. Likewise, you can find any number of values of the polynomial for the corresponding values of the variable x. You can give any real number. Now, you can see from this that the value of the variable is independent. That means you are free to give any value for the variable, and correspondingly value of the polynomial changes. So value of the polynomial depends on the value of the variable. So this x variable values we can take as the first coordinate and the corresponding value of the polynomial as the second coordinate. We can form ordered pairs. Or x values we can take. The first value of the variables can be taken as the x coordinate and corresponding value of the polynomials can be taken as the y coordinate. By considering like this, we can have ordered pairs represented by this given polynomial. So you know that ordered pairs, we can plot these points on a coordinate system or Cartesian coordinate system. Remember the name. Cartesian coordinate system is the system by which we divide a plane into 4 quadrants by drawing a pair of mutually perpendicular number lines, and each point on that plane can be exactly plotted by a pair of values ordered by x, y, where first value is the x coordinate and second value is the y coordinate. So these points ordered where x, p of x, value of the variable as the first coordinate and value of the polynomial as the y coordinate, we can have ordered pairs. So plot these points on a graph Cartesian coordinate system, and by joining these points we will get the graph of the given polynomial. So this is how you draw the graph of a polynomial, by considering different points satisfied by x and p of x of the given polynomial. Now in this example, the different ordered pairs that you get corresponding to the polynomial 2x minus 4. When x is given 1, the value of the polynomial was negative 2. So 1, negative 2, 2, 0, ordered pair 3, 2, ordered pair 0, negative 4, ordered pair negative 1, negative 6, ordered pair 1 by 2, negative 3. So in each ordered pair, the first coordinate or first value is the value of the variable and second one is the value of the polynomial. So we get ordered pairs corresponding to this given polynomial. And now we can go for plotting these points on a Cartesian coordinate system. See. So this is a Cartesian coordinate system where there are two number lines, horizontal one and vertical one. Remember the plotting of graph that you have seen in the lower classes. X-axis, horizontal axis, and Y-axis, the vertical axis. And each point is plotted, for example, ordered where 1, negative 2. The first value is the value along the x-axis. And since it is 1, it is x-coordinate 1. Moving 1 unit to the right side of the origin. And y-coordinate is negative 2, so going down 2 units to the down. So this is the point A, ordered where 1, negative 2. Similarly, the second point 2, 0, ordered where 2, 0, x coordinate 2, y coordinate 0. So it's on the x-axis because y coordinate is 0. Then ordered where 3, 2, x coordinate 3, y coordinate 2. Ordered where 3, 2. Then ordered where 0, negative 4, x coordinate 0 along the y-axis and y coordinate negative 4. So 4 units down to the down. So this is the point ordered where 0, negative 4. Then x coordinate negative 1, y coordinate negative 6. This is the point. Then x coordinate 1 by 2, y coordinate negative 3. This is the point. So plot these points corresponding to each ordered pair. And you can see from the graph that all these points are in the same straight line. So we can get a line passing through these points. These are not the only points represented by this polynomial. There you can find any number of points. Plot these points and all these points are in the same straight line. So it represents a straight line. Okay, so this is the graph of that polynomial 2x minus 4. Okay. Now see, this was a first degree polynomial. 2x minus 4 was a first degree polynomial. And you have seen that it was a straight line. And that is why it is given the name linear polynomial, because it represents a straight line. So first degree polynomials will represent always a straight line, and that is why they are known as linear polynomials. Now you have seen that 0 of a polynomial is the value of the polynomial becomes 0. When you give a particular value for the variable, the polynomial becomes 0. That is known as a 0 of the polynomial. And for this polynomial 2x minus 4, x is equal to 2 is the 0. X is equal to 2. So you can see from the graph, see, when x is given the value 2, polynomial takes the value 0. So this is the point corresponding to the 0 of the polynomial. And that point is on the x-axis. It's on the x-axis. So 0 of the polynomial from the graph is the point on which the line meets the x-axis. Because on that point, on the x-axis, y coordinate will be 0. That means value of the polynomial is 0. And the corresponding x value is the, x coordinate is the 0 of the polynomial. So 0 of this graph or the polynomial is the point where the line meets the x-axis. So that's a generalization. It's because of the fact that the value of the polynomial is taken as the y coordinate of each point, and the y coordinate of a point on the x-axis is 0. Hence the x coordinate of the point where the graph of a polynomial meets the x-axis is the 0 of the polynomial. And again, you know that a line will intersect the x-axis only at one point. So a linear polynomial can have only one 0. Okay. So now we consider the method of plotting graph of a quadratic polynomial. For example, p of x is equal to x square minus 4. Likewise, we can find infinite values of the polynomial for different values of the variable. Now let us consider some of the values of the variable. Say x is equal to 1. When you substitute x is equal to 1 in the polynomial x square minus 4, you get to 1 square minus 4, that is negative 3. X is equal to negative 1, you get the value of the polynomial negative 3. Similarly, when x is equal to 2, 2 square minus 4 is 0. Then negative 2, 0. Then x is equal to 3. X square minus 4 becomes 5. So these are some of the values of the polynomial and corresponding for the corresponding value of the variable. Now the ordered pairs that you get from this example are ordered pair 1, negative 3, ordered pair negative 1, negative 3, ordered pair 2, 0, ordered pair negative 2, 0, and ordered pair 3, 5. So we can plot these points on the graph Cartesian coordinate system. See, these points are plotted. Ordered pair 1, negative 3, 1, negative 3, ordered pair negative 1, negative 3, ordered pair 2, 0, ordered pair negative 2, 0, ordered pair 3, 5, etc. See, this is the representation of the points that you have selected for this polynomial on the Cartesian coordinate system. You can see from the position of the points that it is not in the same straight line. Now we can have a freehand curve connecting these points. There are many other points satisfied in this way. So we connecting all such points, we get a curve of this form. Okay, so this was a second degree polynomial and it represented a curve. Okay, so see compare the two graphs. The first one was a linear polynomial and the graph was a straight line. That is why linear polynomial, and this is a quadratic polynomial, and the graph of the quadratic polynomial is a curve, especially it is of the U shape, and this kind of curve is known as parabola. Okay, so the shape of the graph of a quadratic polynomial is a curve known as parabola, which can be opened upwards as you have seen in this figure and opened downwards in the inverted U shape. U shape and inverted, both these shapes are known as parabola, parabolic form. So second degree polynomials will represent parabola. And here also you can see that the zeros of this polynomial x square minus 4, see the significance of that from the graph. There are 2 points where the graph, this parabola intersects the x-axis. So both these points will be the zeros of x coordinate of such points. See, one is 2. When you give the variable x is equal to 2, the polynomial becomes 0. Similarly, when x is equal to negative 2 also, polynomial becomes 0. So for a quadratic polynomial, there can have 2 zeros. See, here from the graph, the curve is intersecting the x-axis at 2 different points. So these are the 2 zeros. There are 2 zeros and the zeros are given by the x coordinate of these 2 points. So it is x is equal to 2 and x is equal to negative 2 are the 2 zeros of the polynomial that you have considered. So the number of zeros will be the number of points where the graph meets the x-axis, and the zeros are given by the x coordinate of the points where the graph meets the x-axis. So this is the significance of graphical representation of a polynomial. So a linear polynomial will represent a straight line, and second degree quadratic polynomial will represent a curve. Similarly, higher order polynomials, any higher order polynomial also will represent curves, and the number of points where the curve meets the x-axis will be the number of zeros of that polynomial, and zeros are obtained by the x coordinate of such points where it meets the x-axis. Remember, it meets the x-axis. Now go for answering the questions given in your NCERT textbook, exercise 2.1. There are different graphs given. Go for answering it. Okay. So we'll meet in the next class. Okay. Thank you.